So in this video, we will generate the dataset of a normal distribution of a normal cumulative distribution function using ERF and NORMDIST. Now, we will use ERF for this in the first part. So this is equal to RA formula of 1 plus ERF. We start with ERF. ERF of the x values over square root of 2. And we continue. We add plus 1. That is 1 plus, and then 1 half, or we just say 0.5 times. And then another side we will have also 0.5, 0.5. This can be calculated using the normal distribution, which is RA formula. NORMDIST of the x values, where our mean is 0 and the standard deviation is 1, and we choose 1 for cumulative distribution function. And we have the exact same values. We can chart this and regress it to its maximum. So we insert the chart, and we use the scatter chart. And we'll we'll regress it to a trend line that fits best. That's a polynomial, and we'll choose the highest level, 8. I will show the equation. So here we have the best fit, r squared equals 1. And we'll calculate this values of B of the regression coefficients B0, B1, B2, and B3, B4, B5, B6, B7 to B8, because we have 8. We have a population of 8 here. So we will regress it without degree of freedom. We begin with the x to the 0 column, because RA formula of the x values raised to the power 0, or this 0. And we lock the reference, and expand the 1 comma x matrix. Now that we have the 1 comma x matrix, we can enter the LINEST of data y for the more normal distribution, data y, and data x. You'll notice the value B0 matches to the trend line, 0.5, B1, 0.398, rounded up as 0.399. B0 is 0 because this is very small, 4 times 10 to the minus 23. B3 is 0.0656. This is 0.0656. B4 is 0 because this is very small. That is 2.08 times 10 to the minus 22. That's very small. So that's why it's 0. Our B5 is 0.008794. It is rounded up as 8.79 times 10 to the minus 3. And B6 is this value, very small, 2 times 10 to the minus 22. That's why it's 0. And B7 is 5 times, that's 5 times 10 to the minus negative 4. So we change that to scientific. So that's negative 5 times 10 to the minus 4. And the 8 is minus 3.17 times 10 to the minus 3, which is already 0. We also enter the LINEST for this portion, which is, they are the same anyway. So LINEST of data y and data x. So we still get the same value. We will just have to change it to scientific. So we get the same values. And because they are, this r squared is perfect 1, the values in blue, the data sets in blue, are covered by the data sets in red.